Lines. How are the measures of angles related when parallel lines are cut by a transversal? So as I look over this essential question, there's a couple of words here that pop up as to, reminds me, hey, you probably want to know what parallel lines are, and you're going to probably want to know what a transversal is. Now, parallel lines you should be familiar with already, and so I'm going to talk about two different types of lines. There's parallel lines and perpendicular lines. The symbols for parallel lines kind of looks like the number 11 or like two lowercase l's, but those that symbol there tells you that the lines are parallel. Perpendicular lines look like an upside down T, and that tells you that they meet at 90 degrees. Okay, so that's parallel versus perpendicular line symbols. The definition, more or less, parallel lines are two lines that never cross, they don't touch. Okay. And perpendicular lines are two lines that cross once at 90 degrees. And that's why you'll see like a little box right there. It tells you, indicates that it's crossing at 90 degrees. If you were to draw them, this is an example of parallel lines, right? You go across, or lines because they keep going forever. They never touch. And this would be an example of perpendicular lines. How we describe this in real life, a number of things that were popped up here. Train tracks. Could be parallel lines, the stripes on a flag, the equal symbol, right? The out of bounds on a particular field, the yard markers in football, right? The field goal post, the posts themselves are parallel. Perpendicular lines, it might be like a street intersection or a plus sign, right? Those are perpendicular. The cross, field goal posts. Same field goal post, except now instead of talking about these two lines, we're talking about these parts of the post, right? Or this part of the post. Those would be all considered perpendicular lines. Now we're talking about transversals. Okay, a transversal is a line that intersects two or more lines. And it's usually two parallel lines. So for instance, I'll show you a picture here that you're going to want to draw in your notes, and we'll talk about all the little parts that are connected. These two lines here, let's call this line M and line N. And then I have line L. Line L is the transversal. It goes through the two other lines. Okay, and in this case, line M and N are parallel. So these are parallel lines, and this one cuts through it. And then I went ahead and just numbered all these different angles, right? We've got angle 1, we've got angle 2, angle 3 and 4, 5, 6, 7, and 8. Those are all the different angles that this transversal creates. And so the first type of angle I want to talk about are interior angles. Okay. So in this case, interior angles are all the ones that are inside the parallel lines, right? And so this case, angle 4, angle 3, angle 5, and angle 6. All these are not angle 8 or angle 7, but the other ones here are all interior angles. They are inside of the parallel lines, okay? So interior angles. So next would be exterior angles. So exterior angles, just like interior, except this is exterior, are going to be outside of the parallel lines. Okay, so these are called exterior angles. 1, 2, 8, and 7, or 7 and 8, all exterior angles. The next are called alternate interior angles. Alternate means one on one side, one on the other. Interior means inside, and angles. So alternate interior angles. So the ones that would be alternate, look, we're looking at this transversal, one's on the left, one's on the right, and they have to be inside. So 4 and 6, 4 and 6. These two here, in comparison to each other, are called alternate interior angles. One is on the left, one is on the right, and they're both inside of the parallel lines. There's another pair of alternate interior angles, and that's 3. I'll put double lines for those, and 5. These two here, 3 and 5, one's on the left, one's on the right, and they're both inside the parallel lines, are called alternate interior angles, and they have the same measurements. So angle 4 and angle 6 have the same exact measurement. Angle 3 and 5 have the same measurement. All right, that brings me to alternate exterior angles. So just like the one before, it's going to be alternate. So there's one's going to be on the left, one's on the right of the transversal. And this time they're going to be exterior, outside of the parallel lines. So in this example, number 2, angle 2 and angle 8. One's on the left, one's on the right, and they're outside outside of the parallel lines. Those two are the same measurement, as well as angle 1 and angle 7. Those two are also alternate exterior angles. One's on the left, one's on the right. They're both outside of the parallel lines. And again, these have the same measurement. So angle 1 will have the same measurement as angle 7, and angle 2 and angle 8 will have the same measurement. Last one I have here is corresponding angles. So a corresponding angle is going to be one that is on the same side. Okay, so we've talked about ones on opposite sides. This time on the same side of the transversal. Okay, same side, but one's in the exterior, one's in the interior. So angle 1 and angle 5 are corresponding angles. Angle 2 and angle 6 are corresponding angles. We also have angle 4 and angle 8. Those are corresponding angles. And lastly, angle 3, 2, and angle 7 are corresponding angles. Okay, and again, these will have the same measurement. Alright, so just a refresher, if you see this symbol, it looks like an equal sign with little, almost like an approximate symbol, half approximate, half equals. It means congruent, and congruent is to be the same measurement. So in case you see me use that, you know what I'm talking about. Alright, so let's look at an example here. It says, look, if angle number 1, which is this one right over here, if angle 1 is the measurement of angle 1 is equal to 150 degrees, find all the other angles that are 150. Okay, so if you notice here before I move on, the little m means measurement, and then here it's not a less than symbol, right? Less than looks like this. This is an angle. Angle is going to go all the way down to the line and go across. So measurement of angle 1. Okay, just in case, just so you know the difference between those. So if this is 150 degrees, find all the other ones that are also 150 degrees. So let's take a look what I did here. Angle 1 and angle 5. These two here are the same. They're both going to be 150 degrees. Why? Because angle 1 and angle 5 are corresponding angles. They're on the same side of the transversal, assuming that M and N are parallel. Same side of the transversal. One is on the outside, right? These are the parallel lines, so outside of the parallel lines, and one of them is inside. So those are congruent. Those are the same. Angle 1 and angle 8 are also congruent. Why are they congruent? Because alternate exterior angles. Angle 1 is on the left, angle 8 is on the right, and they're on the outside of the parallel lines. So alternate exterior angles. The next one would be angle 5. So now that I've already proved angle 5 is the same as 1, I know angle 5 is 150. I know that angle 5 and angle 4 are congruent because they're alternate exterior angles. Now we're talking about, now we're talking about 2, right? 5 is on the left, 4 is on the right, and they're inside of the parallel lines. So alternate interior angles. There's one other angle measurement. Actually, no, that's it. So those are the 4 that are exactly the same. So we could say, therefore, measurement of angle 1, measurement of angle 5, measurement of angle 4, measurement of angle 8 are all 150 degrees. Now careful, this is not an L, okay? This is angle, just to let you know. All right. So there is a way to figure out what this measurement is here. Angle 2, or angle 3, or angle 6, or angle 7. There is a way to figure that out, and let's see if we remember this from last year. All right, so from the past, you've learned about supplementary angles. Supplementary angles are 2 angles that add up to 180 degrees. So 180 degrees, if you're not familiar with what 180 is just like that. It's a straight line when you add it all up. Okay, 180 degrees, half of a circle. So if I take a look at this example, if I have an angle here, and this is 60 degrees, I know the rest of it is 120 because 60 plus 120 is 180. Okay, so these are called supplementary angles. 2 angles, when you add together, give you a straight line, 180. So if we use supplementary angles, we know that from the picture above, and I just kind of redrew this here, I know that, look, if this is 150 degrees, this over here must be 30 degrees. Why? Because 150 plus 30 gives me 180. So all the way across is 180, and this is 150, so the remaining part is 30 degrees, right? 150 plus 30, 180. So going back to my picture above, I can tell that measurement of angle 2, 3, 6, and 7 are all 30 degrees. Why? Well, because let me go back here. If I knew this is 150 degrees and I block everything else out, that must tell me that angle 2 here is 30 degrees. Going this way, I got a straight line, so if that's 150 degrees, then angle 3 is also 30 degrees. Going backwards, if I just look at these two angles, if this is 30, what's left over? Well, I already proved that this was 150, but there's another way to prove it. And then again, from the previous question, I had already figured out that all these here were 150. So I come back over here, 150 plus what gives me 180? Well, that's 30 degrees. And then the last one here, 150 plus what gives me 180? Be 30 degrees. All right, so that's most of the information you need to solve your problems. We'll do a little bit more examples tomorrow in class.